Do you want us to check if it's streaming?
I think yeah, can you check? I think it's streaming.
Could you remind me? Because it was not working with that before.
Mm-hmm. Can someone check if it's streaming? Nice.
It is?
Okay.
Yeah.
Okay. Okay. Nice. So, welcome to Intro to WebSockets. I made like a small app to play the slides. It's like I saw this in a meetup and I really liked it. It's like so this might be one or two of the of the slides app, but it's it's doing the function. So okay, so I did a lot of research to try to explain this properly. But anyway, if I say something wrong, I would appreciate if someone watches this and wants to correct me to send me an email. So yes. Let's go to the next. Welcome to Intro to. So, how do we communicate on the web? So, I don't know, when the web started, when like more than 20 years ago, we yes, yeah. So we use HTTP, which is a protocol that is called like that. It's a hypertext transfer protocol. So this protocol has a client-server architecture, means that the client is going to send a request to the server, and then the server is going to send back a response. So, for instance, if we want to um, access some websites, we just send the request to the server, and then the server is going to check that request, and then it's going to send the response. So now I want to ask you if I'm going to ask you to raise your hands. Who thinks that the server can initiate a communication with the client using HTTP, and who doesn't? So first, who thinks that? I'm not going to say names. It's okay. It's just someone thinks that the server can initiate a communication with the client using HTTP. Does someone think that the server can't initiate a communication with the client using HTTP?
Instead of being the client, the one
Yes.
initiating that.
Because I want you to think, for instance, how do feeds work? How does Gmail work? How does Facebook work? Like when you are online, you can see if you have a new notification, where does that come from?
Okay.
So,
But
what do you think?
could it be that the web page from the client is requesting to update and
Yeah, but do you think that's how, I don't know, HTTP works? Like, because HTTP, sorry, uh, it was designed to work. Okay, I'm going to answer because no one wants to raise their hands. So,
So Facebook Messenger, no, definitely not. Feeds. So by feed, you mean what?
for instance, when you subscribe to a blog, for instance, you have new an RSS feed, for instance, you get when there is a new post, you're going to get a notification.
okay.
You can initiate it on HTTP. So the server can send a message to the browser to the client and say, hey, I want to send you this information, and the server can don't worry, I'm going to explain it now. So
Generally, yes, all of those.
Yeah.
Certain parts.
using HTTP, you can't. It's always the client who has to start the communication.
Uses all the protocols.
Yes, you can use. I'm going to talk about the most popular technologies to get around of that, because when the internet, I mean, on the beginning it was only about uh, transfer data. There wasn't many. Like for instance, a simple website would not need to send you notifications. So when it started to evolve, some like workarounds started to get developed, and the most popular technologies used to get around this problem were X, XHR, which stands for you can do it using an XML HTTP request. This is the oldest one. Then there's another technology called server-sent events, and then WebSockets. There's a few others, but these are the most popular. So the first one was is the oldest one. It was XHR. So the communication with XHR works a bit like this. So in the beginning, the requests were meant only to, as I said, to only get a request from the client and a response from the server. So if it would be a human communication, it would be something like. But first, I have to explain what is basic polling. Sorry.
So the conversation will always start with the client.
Yes. So a way that was found to get like some sort of updating data from the server was basic polling. That is like using a method called set interval. It's going to it's the amount of time you set it. It can be 5 seconds. It can be 2 seconds. It can be 1 second. It's going to run again some code. So if you make a request to the server and then you set it to run after 1 second, it's going to send another request. It's going to set another request, that indefinitely. So the communication will be something like this. So server, any data from me? No. Server, any data from me? No. So like this all the time. Sometimes you're going to have some data, sometimes not. But the requests are going to be sent forever until the client gets closed. So it's a bit annoying from part of the client. So, so I think we can already see that this was not very efficient. Like it would waste resources because the client is all the time asking for new data. Yeah, so it's very efficient. And another problem is the latency, because you are setting an interval to wait for new notifications. So imagine you need something more real time. Sorry, something that like it wasn't possible to make something. Imagine like the way Google Maps work, for instance, and you are driving a car, it won't be fast enough to get the information back from the server. So after basic polling, there was another technology developed called long polling. So it's basically the same. It's with HTTP an HTTP request, but the thing is on the header, because when you make a connection, when you make a request to the server with HTTP, you are sending some information that the server is going to process, and then it's going to send a response if it's okay with the headers you sent. So in long polling, there was a new header introduced that is going to allow the server to delay its response, among other things. So it can also it was also able to send the response in several times, like send the first part of the response, then the next one, then the next one. So you could do that until you have a response. You're not going to make another request unless you set it to do that. So the conversation would be something like this. Uh, do you have any data for me? Yes. Please take your time. The server will say, not yet, but thank you for your patience. You're not so annoying as before. I'll send it as soon as I have it. Oh, yes, it's on its way. So then after that, it would send another request. So with this, we still have to send the headers with each request. So still we have some, because imagine we are always the same client, and we are going to still have to make the server recognize us each time we need a new request. So each time we have a new response, we are going to need to send another request. So it was much better than short polling or basic polling, but still wasn't ideal. So the pros of long polling is it has less latency than basic polling, and yeah, it's more efficient. But it still has the HTTP overhead, means the headers that are sent with each request. So this is going to imply some latency, and it's also, we are using a tool for something that this isn't intended to be. So because of this, there are going to be some situations that are difficult to handle. For instance, it's difficult to manage the order of messages. You can get a response before finalizing to send the request. Imagine you have a set interval set to make a new request, and you still didn't have the response back. So that's going to generate some issues and other more complex.
The second one, it's not dependent on the first one.
No,
Ah,
you depends. You can make it recursive, and then when the well, I don't know if we all got to expect. Like recursion means that a function that calls itself inside it again. So when something happens, then it will call itself again. So when you get the response, so call yourself again. That's one way of doing it, but also can be done with set interval. So it, it could have these problems. So yeah. So now we go to server-side events. This is much better. This works with an interface called event source. It's an, an API that has several methods that you can call on the browser. So basically, it means that you have a connection with you send an HTTP request to the server asking to keep the server connected with you. And after sending the first request, the server is going to be connected with you until the connection is closed. So the thing is, it has some issues because it's just one way. So the only interaction the client does is to start the request. So in a real conversation, it would be like, so server, keep me updated with any new data you have. Okay, so the server is going to start to send messages. Hi client, how are you? I hope you're fine. The weather here is sunny. Client, how are you doing? Hello, hello, hello. Are you still there? Until the server is going to realize that the client is not longer there. So the server is like, is one way direction of communicating. So it could be very it could be useful for some situations, but still is not ideal. Okay, so is the process that it has is one request. It could be a good choice. Imagine you are just sending, updating some, for instance, the feeders we talked about before, or you're just updating the client on some data. It's a good choice because it doesn't have the issues that we had with XHR. The problem is it's unidirectional, and the server doesn't always realize when the connection is lost. So we are, yeah. So now we finally get to WebSockets. So the WebSocket specification is an API that establishes a socket connection between the client and the server. So there is a persistent connection between client and server, and both parties can send data at any time. So with server-side events, we had a persistent connection, but it was unidirectional. Now we can send it in both directions. The conversation now, it would be a normal civilized conversation. So it would be, hi server, I'm client, nice to meet you. So this would be the request from the client. Then the server is going to send a response. Then there's going to be a handshake that is literally called like that. And then instead of talking on HTTP, they are going to talk in a new protocol that is called WebSockets. And now we can have a civilized conversation. Now I'm going to explain how to actually work with WebSockets. Well, first of all, do you have any questions? Because I went quite fast.
Do you know if, regarding to security, it may be unsafe, like that the server may.
Well, I think this works in like on the first request, you're still going to send an HTTP request. So on the header, the server is going to check if the client is reliable to connect with. So there's going to be some authentication also with tokens, and but I didn't get into it because it's a bit more complicated. But once the server can check that the connection is going to be secure, they are going to change. Also, if the sorry, I'm going to rephrase. Sorry, the client is going to send a request to the server, and on that request, there are the headers with the information of the client, and in that headers you have the identification of the client. You can have a key token for security, and also you're going to ask the server if the server supports WebSockets. So when then the server receives the headers, it's going to check that everything is okay. Then it sends back the response to the client, and if everything is all right, they do the handshake. Then the connection is upgraded to WebSockets, and then you can start to send data both ways. The way to do it is quite simple. There's only two methods and 4 events to listen on. I'm going to show it on the code now. Well, I can show it here. Yeah. So before the code. So the methods are socket.send. I don't know if it can be seen. I'm going to increase this one. So yeah, with socket.send means to send the data. Socket.close to close the connection, because the connection is persistent. So when you want it to close, you have to close it. The events like open, message, error, and close. Open would be when the connection is set. You can set some code to run listening on this event. Message, when you receive a message, either the client or the server. Error, if there's any error, and close when the connection is closed. I'm going to show it on the code right now to see how this works. So first of all, we have to specify the URL to the server. In this case, it's a localhost. You set it as a new instance of WebSocket. Then once the connection is made, you can start listening to the events. So it's quite straight away, I think. So when on open means when the connection is done, do this run this code. In this case, is console.log. Then on each message, run this other code. So it's going to be receive the message and then add the message to the list of messages we have in order to display it. And then on close, just do this other code. So we can also set it to try to reconnect when there is a disconnection. And that's pretty much it. The rest of the code is just normal React, like to update the messages and display them on the screen on the browser. So I'm going to show you how it works. It's working. So oops, wait a second. Oh, no. This was set up, but now I have to set it up again. I'm sorry for that. I had for Windows. I'm going to mention Sebastian because he mentioned me yesterday, and I want to return the favor.
That's the reason.
So now imagine we have this is the chat. We have the names. We can put any name, but Sebastian is a nice name. He's nice, so we can have for Sebastian. So it'd be like hello. You can see it's updated on all the clients that are connected to our WebSocket server. So now another message. Oh, hi. You have the same name as me. Oh, it's working. So I can't believe it. Believe it. 3 people with the same name. So far it's 3. Same name. No, 4. So we can see that it works. It's quite easy to make it work as long as it has some issues when you want to scale it. Imagine you have 1,000,000 users and they are all connected to a server at the same time. That is not like going to crash, but you need to think how to manage that but it's way beyond what this is, like an introduction, because we are still not at that level. Maybe in the future, hopefully. But yes, I think you can use it on any modern server. It doesn't have to be AWS. They probably you can. I don't know. I never used AWS, to be honest, but it would make sense to be able to use it because it's a modern technology.
It's just a cloud server.
Yes.
It's the same as like a normal server, like you have a mini server for a laptop.
Yes.
It's the exact same, but it's obviously not remote. It's not local anyway. It's a data site.
Yes.
No one knows. No one where it is. You just pay for the space.
And they also have an option to balance the load, right? So if we did hit a million
Yes,
users,
that's the issues
they
that
can
yes.
adjust the amount of service.
Yes. Imagine you have 1,000,000 connections, and so that has some issues because you have to redirect it to get if you want, for instance, imagine to get the same data on all the clients, you have to make the servers have the same data also, and that's not so easy. But
respond with like the same level.
Yeah, like for instance, now you in this example you send a message and it's going to display on all the other three clients. Imagine you have 100 and then 50 are connected to one server, 50 to the other one. So if you connect to one server, you're going to get the messages from that server. You need to find a way for the servers to share data between them. Yeah, and I don't know, is there any questions? No? Okay, so thank you.
I was curious with myself, SSE, SSE? That's what
SEE, server, server.
where only the server talks.
Yeah.
When is it used?
When is it used? Imagine you have, for instance, you want to check the stock prices. You don't want to buy it, but you don't only want to display it. So it's efficient to only listen from data from the server because you only have to set the connection once. And then you don't have to communicate at all from the client. So yeah, for instance, I don't know, there's others. But if you have, for instance, if you want to do something like, I don't know, real-time gaming, for instance, if you have latency, that's not going to work, for instance.
Nowadays, when you go on a website and they come to talk to you directly, asking you for help, to chat with
Oh, a chat, yeah. The WebSockets they are used on chats. Like you can use the other technologies too because they. I mean, if you wait 3 seconds, you might not realize if that person is answering straight away or just waiting 3 seconds. So, but yeah, for like real time things, it's better to use WebSockets, and it's also more efficient. I read some statistics. It's like it has like between 500 and 1,000 times less traffic from headers from the requests because you only have to make the initial request and then uh, on each message is going to send. I think it's a few bytes. I don't remember, but it's not even 100 bytes before it. Yeah, and yeah, so. Yeah. No, thank you.
quick one.
Yes.
You mentioned about WebSockets. I know that we use it in our app, but what other WebSockets have you come across?
Say it again.
What other WebSockets have you come across? Like Socket.io is one that we use.
Yeah, that's a library because there's some. Imagine Socket.io does things. For instance, not all servers support WebSockets. So Socket.io, if the server is not supporting WebSockets, is going to default to long polling. So that way the connection is always working. And also I think it manages also the load balancers, I think is the word, when you have many connections at the same time of different browsers. I'm not sure. Like there's some issues that you might uh, run into that the libraries solve. That's right. That's the reason of using that. Because the basic way to use WebSockets is quite simple. There's only 4 events and 2 methods. So yeah.
So you only need the URL from where you want to connect.
And then on the server you need to set the server to listen to that connection. And then yeah, I can show the server file.
You still use the library, right?
Yes. This library is called WS. It's only for the backend. But it's just for three functions. No, for three. Yeah. So, any more questions? Okay. So, would it be okay if I stop streaming?
Another round.
Thank you.